Hi there. I hope you can hear me okay. Right. So welcome to another live stream. Today I'm going to evaluate Google MediaPipe, which it's probably not known to many people, right? This is a open source toolkit from Google, which can work on multiple platforms like Android, iOS. It can run also on JavaScript on a browser, and it's also able to run with Python. Okay, so this Google MediaPipe actually offers quite a lot of out-of-the-box features that we don't actually need to that we can just use out of the box, right? Like we have segmentation masks, we have face mesh, we have hand tracking, human pose detection and tracking, hair segmentation, object detection and tracking, face detection, holistic tracking, and where I think you can actually use gestures as well to control, like to do things, interesting things. And then you have 3D object detection, and you also can use a custom solution. Like you can actually train your own model and deploy it with the Google MediaPipe. So it also gives you that feature. I actually looked at these frameworks some time ago for another project. It was, and one thing in that project we had to evaluate whether Google MediaPipe would be a better solution than just, for example, relying on the native like ML solutions that each platform has. You know, even Android has its own. It has something else, right? So normally when you develop for Android, you have the ML kit from Google. This is officially supported, okay? And then if you're going on iOS, you're going to use Core ML, okay? Core ML is actually very good as well, right? So we were looking at Google MediaPipe as perhaps a way to, you know, it's a bit like using React Native or Flutter, right? The idea is to try and write code once and then you can reuse it in all platforms. We didn't go with Google MediaPipe just mainly because the actual customer in this case, they only wanted to target iOS anyway, so there was no point to really try to use MediaPipe. Anyway, I was quite impressed because it has a lot of features here, okay? And the goal of this live stream, I've taken here I put some objectives here for today, and this is an objective for like the weekend, because I know. No, not this one, in a Raspberry Pi. If I want to try this on a Raspberry Pi, it's going to be a bit of work. Yeah. So I'm not going to do it tonight because I don't have enough time. But what I would like to do today, first is to understand what Google MediaPipe can do. I've already given you an overview of what it can do, but let's maybe spend 5 minutes looking at it. Then let's try some examples. And I don't want to spend a lot of time installing anything, so I'm going to try examples in Google Colab or the ones on the browser. And then also hopefully have an opinion whether it's going to be feasible to deploy MediaPipe on the Pi. Okay, and yeah, that's about it. That's what I want to achieve today. Actually, all of this functionality here is crazy, right? So for my particular project, I don't know if you know, I'm working on a wildlife camera for my garden, and I've been spending I've spent quite a lot of hours already training a custom image classification model that can detect, you know, don't be blown away by this, it can detect cats, foxes, and birds, okay? Because this is the only thing I get in my garden. There's no point to try and detect bears or lions or anything like that. So I already trained the model, but I also want to use, sorry, I have some background noise. I'll just wait a second. It's very hot today, so I have to keep my window open. So in my case, yes, I have an image classification model that I'm going to use, but I need a feature. Okay, one of the plans first thing I want to do, I want to implement some kind of motion detection with OpenCV. Okay, that's the first thing that the camera will do motion detection. The idea is I don't want to be running a lot of, I don't want to be draining out the battery if there's nothing there for the camera to detect, right? So if we see anything moving, right, then I'm going to, the idea is to call, for example, Google MediaPipe and use the, the object detection or person detection functionality here, and then see, okay, is there a person in the picture or not? Or is there an animal or something like that? And if we find there is an animal, then we will actually call the custom classification model. Okay, so let's have a look, for example. Well, hair segmentation is quite cool. Let's start from the top. What is selfie segmentation? Selfie segmentation. Okay, this is probably for the background itself, a replacement. Just like I'm using NVIDIA Broadcast, which allows me to avoid having to use a green screen, and it does segmentation. Okay, here's some examples on how to use this functionality. And it can also be used in JavaScript, which is awesome. Right? Okay, so I have here a request. Hi, Shital. You're asking me to do a demo, to try the demo with synthesizing dynamic talking face with implicit attribute learning. Is that something that you found that Google MediaPipe can do? Yes. Don't see that in the functionalities here. Anyway, so the face mesh is what for? So the face mesh is a functionality that allows you to detect where the face is, and then you can apply effects like you have, for example, on a Zoom conference call where you can add some, I don't know, sunglasses or a hat or whatever. Okay, this is cool. Okay, and then we have hand tracking. It can be useful, for example, if you want to implement some kind of action with gestures. I've always had this dream, like I'm just going to use my hand to stop the music or, right. And then we have human pose detection. This could be good, for example, for teaching someone how to do like, in this case, the example is fighting, or we can, something with like yoga or some kind of complicated dance. Cool. Can do that also for us. It's supposed to be very fast. So MediaPipe is actually developed in C++, right? And it can it's very fast in theory, but also it's quite complicated to set up. So we have holistic tracking, so we can specify like different poses. Very cool. It's a lot here in terms of functionality. If you have to develop all of these, you're going to spend a lifetime. So there's no way anyone. This is probably something that could be useful for me. There's a lot of functionality. Okay, face detection. Wait, face detection is not really something very unknown. Okay, and more solutions. The cool thing about MediaPipe, you can run it on the devices themselves. You can also run it server side. Cool. So let's look at some code. Okay, this is the GitHub project. If I look, maybe a bit out of date. I hope that there is things going on after 2020. And then we have, I always like to look at the pull requests to see when it was last time something was fixed. Okay, there's some pull requests here and there, right? So the last one is 11 days ago. It's not a very busy project, but at least it's being updated. Okay. This is the GitHub project, and I wanted to try some solutions in Python. And the easiest is to start with Google Colab. So let's try face detection on Google Colab. Maybe in a separate tab, it's easier. Face detection. Okay, let's install MediaPipe. See how difficult it is. So we installed MediaPipe. So we download the images from unsplice.com. So we need to, okay, they are suggesting us to download some images ourselves. Okay, so let's do that. I'll try my own images if this goes well. First one. Then second one. Okay, I need to download the second image. So the second image. So we've uploaded 2 images. Okay, there's an error. Went wrong. Okay, maybe I need to... I did upload it. Oh. So this is the method. Upload a short range. So the first photo was uploaded, but I don't think the second one was uploaded. Was it? 1544. Okay, let me try and run this again. Short range. One. Full range. They're actually they're already there. So we are doing something. Okay, let's do a print. So something is actually broken in this notebook. So I need to fix it. Oops. So there's 2. It's 1 image only. There's some so I have a question. So I have a question. If yeah, sure, I can. I don't have any knowledge on black holes and dark matter, so I think I'll pass on that one. So I have here a problem, like a bug. So I need to figure out what the problem is here. So I have a method. It's trying to resize and show the images that we pass in as a parameter. Then we have here an iteration. It's a list comprehension, I think. It's going a dictionary. So for name in upload is short range. Print this as well. So it's all empty. So I printed this, it's empty. But this one, and it's empty. Maybe anyway, I think I'm going to I think I can avoid this problem simply by just copying the this is going to be what? Nth time. Throwing up something here. Interesting. I am read. I'm just adding some debug here just to see what's going on. So we have no attribute shape. We need to add F here. I'm just trying to understand what's actually in that name variable. There is a file there, right? Not sure why it's not opening it. Maybe it's better to just specify the actual full path. It's all good. The name is there. The image is not, right? Actually, because I changed the code. cv2.imread. Okay, put it back together. This should open the file. So let's have a look at the definition for imread. Sorry, we have, so imread is supposed to load an image from the specified file. So it's a path you can give it. And then it returns an image. The question is, what happens if there is it's not nothing special there, right? So why it's not working? I have to pass in a path. None. I think it's doing something. So obviously these collab notebooks have not been updated recently. Otherwise it would work. So image equal to none. So this is not doing. Okay, I think it can't load the image. Let me just try some more straightforward image. Maybe I should have downloaded this format. Okay, I think I made a mistake. Okay. I don't think it's able to read that format. That's probably the reason. So I'm going to upload this in JPEG format. Thank you so much for your comments. So the image here should, oh, okay, I shouldn't have used, okay, I'm going to undo everything I've done here because I've just realized I think the problem is the format of the images rather than the images themselves. So I should have used the button download. And it should work. So now we have, okay, I commented out the other code, so I don't need to comment it out anymore. It's uploading. And then I have to upload the second image and it should work. All right, so I think I got to a good, so it was able to upload, obviously. Now let's, fingers crossed that it will work here. All right, yeah, it worked. So it was because the format, it doesn't accept this format, AVIF, okay? So it has to be a JPEG, right? So what's it supposed to do? Okay, so these are the images that have been resized. So it's telling us, so we're going to try the face detection. Well, actually this is helping, the help. So we checking the API, the methods, see them here. And, you know, I'm not going to pay a lot of attention to the actual code. OpenCV is quite standard. It's something I've used before. Nothing special there. Okay, I see this line. Doesn't look like. So it's supposed to be like this. Okay, so it's like a very faint white line. You can see, but this one, it's not full white line. Anyway, here it detects quite well, but the previous model, it couldn't really, I don't think it was able to detect the face very well. Okay, so next would be, okay, let's try another notebook. Disconnect. Now I'm going to try another notebook. So I have to install MediaPipe. which is the same faces. Let's now try this code. So it's resizing the image. And then it's in the same pattern, it's showing us the face mesh class, I think. And the methods we can use to call. And then it's going to draw something now. And it's going to draw the face landmarks. Okay, you can see them here. So this one works quite well. So you can see them around. Yeah, looks okay. Yeah. OpenCV and MediaPipe. Yeah, it's working fine. So this is another Google collab. And then Hans collab. Let's see this one. So hi, Dark Matter. Welcome back. So I'm going to upload another image. Oh, this one has to contain hands. Okay, let me just try another. I have to download another image. Okay, let's download this one. To download. Where is it? Okay, so, I have to run this again. A resized image in the same pattern, right? We're using OpenCV to resize the image. And now we're going to try MediaPipe. Look at the math or the hands class. Yeah, I'm skimming over all this information because for now I'm not really worried about details. I'm just trying out and seeing things working for myself. Okay, and now we've just run MediaPipe hands. So it's detecting like the hands and the fingers and cool. Okay, so we can use that to do some kind of control, maybe an object or something like that. Okay, there's more to this. Okay, you can see you can even draw that in a 3D plane. Okay, right, so this is good. So there's plenty of examples here. Holistic collab, let's have a look at that one. It's nice to have examples for every feature that we have available. And it's good they even offer you images already that you can just download and try it. So let's see which one they pick this time. Okay, so this one I need to download as well. So it's resizing the image. Quite often, machine learning models want squares rather than rectangles or whatever. So you'll see it didn't crop it. It must have, I think it just resized up to 480 pixels square, but it didn't force the aspect ratio. Then we have here like a detailed documentation for the MediaPipe holistic. So we can actually, there's a lot of detail here. It's all out of the box, right? The big effort on MediaPipe is to install it where you need it, but once you have it running, it's actually quite straightforward. You know, you just copy and paste these codes and you try and you customize it to your liking. By the way, the customization can be, you know, you can use just Python, but then if you want to customize it like in more low level, you also have the option to create an interface between the C++ implementation, which is what MediaPipe is written on, is written in C++, so you can customize the interface. But at that point, you are very deep onto the project, right? You already have. It's open source, right? So you can actually make MediaPipe work for you with a lot of, I guess, a lot of effort. But anyway, you have here the landmark detection, like the face detection, the everything holistic. They call it holistic detection. So it detects all your pose and so on. We can even draw this in a 3D plane. Pretty cool. And then we have post segmentation. So it seems like you can basically remove the background, right? So the original background is this one. But of course, this background is actually very easy to segment. I can do that with one click in Photoshop nowadays, yes. But okay, it's not the hardest of backgrounds. So that's what they're doing here. There's still some, you can see some, the background is not completely removed. Okay, so one Google Collab. Let's try another one. So we've tried holistic Objectron. Let's see what that is. Install MediaPipe. The good thing is that the team that were in charge of this project, they actually spent good time creating some good easy demos so that you can actually see what MediaPipe can do for you without having to spend a lot of time coding. In fact, we're spending no time coding other than at the beginning where I thought there was some error in the code, but actually turned out the image I was trying to use was not in the right format. So let me just check what kind of images we need here. Shoes. Second one is shoes as well. Okay, let's try that. We can see. happened there? Sorry, I added the shoe, right? Oh, I forgot to download it. This one. Now, download this again. I should have actual shoes. Shoes. And we have landmarks. Right, so it basically is able to detect the shoes, right? Gives you the coordinates. Okay, now we have another example with chairs. So let's see. Basically, this is detecting objects in the 3D plane. And I remember someone asked me a question before, how to count bags in a photo, or someone else came and asked me how to count leaves. Maybe with this, I don't know. So you can see it detects the box coordinates in the 3D plane for each object. So this is different, for example, from object detection. On object detection, you only get a 2D box. This one, you get a 3D box. Okay, so we have Objectron cut model. Let's try and find caps. I think I could do a coffee now. Let's build it here in London. These are large images, so there's always going to be some resizing required, although in this case don't see any resizing. The model itself inside is definitely resizing. Okay, so oh, hang on, I thought I downloaded the Mac. Try again. Alright, so we are okay. So it's a huge coffee cup. Oh, it's actually using a I just realized one thing. It's using a small machine learning model in TF-Live format to do the detection. Seems like it's been trained on detecting cups, so it probably can do that very well. So if you have to detect the cup, then you have a model on TensorFlow, in the TensorFlow hub, I'm sure. And you can also use MediaPipe. So this is cool. So it's working. Now camera model. What is this for? Right, so here we have another type of detection that we can do. It's kind of the same, to be fair. I'm going to try this one, but actually it's the same. It's kind of pointless. All right, so we have a 3D box for camera, so we can detect cameras as well. Okay, we got the point. It works. So next one. So we have tried Objectron and then Post Collab. I think we've tried. Okay, this is probably almost the end. Okay, let's install MediaPipe again. Now we have upload the image. Oh, then I'll just try that. Let me try a different image so it's a bit different. Okay. This is going to be very similar to the other demo we saw. Just want to see if it's any different. So the help, and then this is the code. You can see can detect the pose. It's a bit hard to see in the image, but it has some lines. Yeah, you can see here. Yeah, you can detect the arms and the legs and the pose. And it can show you more clearly in this image here, like in 3D. So yeah, this is not yeah, this is good. And then we also can do segmentation. This is very similar to the other Google Collab we tried before, so I'm not even sure why it's any different. Right? I think the holistic collab was the same. Now segmentation. Okay, there's pose classification. That's going to be interesting. Okay, now this one's a bit more complicated. It seems like he has to install extra libraries. So we have NumPy, OpenCV Python, and TQDM with Shy. Don't know what that is. Let me check. Oh, it's to create progress bars that you can see when you are doing running the notebook. Yeah, this one. Yeah, this is TQDM. Oh, this is like similar to. I'm not sure what this is from the library or not, but it's what it does anyway. Creates progress bars. Okay, so you have a question, Dark Matter. How is it possible to fix the data bias? Which data bias are you referring to? Can you provide a specific example? Let's see what this one is. Okay, so this one is telling me that I need to create like 2 folders with the required images. But it's not telling me where I can get the images from. That's the problem, because okay, I think I'm going to skip this notebook for now, because it looks like it requires me to find images and look in more detail. Try the next one. I have here another collab. Hopefully it has some sample images I can just download quickly. No, it doesn't have that. Okay, for today, I'm not going to try that. I wanted to see if I could also do the JavaScript demos, because they can be actually be more interactive than Google Colab. Okay, let's try the last one, the segmentation for selfies. And okay, let's run this one. Okay, so let me just clear all my other sessions. All right, so the question is, if you train the model with only X and Y samples, the reality could also go to the Z and beyond, but the ML algorithm would always go always to X or Y. Are we talking about numbers? Because yeah, okay, I think I understand what you're trying to say, is that if we are getting only like in our training data, we only have sample data showing X and Y, right? How can he actually say that the model would not be able to guess that but in reality you can get Z, right? Because Z wasn't in your training data, then the model would never be able to guess that. Yeah, the model would get it wrong. That's called bias, yeah. And in order to fix bias, you need to make sure you have representative data, right? So you need to make sure your data set is includes all possible, or most, I would say like 99% of the values. Yeah. So actually there is a good example of bias because of the data you get. If you look into, there was an AI model that Google released, which was for what was it called? I did an article on that. It was actually a bit like DAL-E. You know, the DAL-E 2? It's like a very popular machine learning model that was trained like on millions of images and millions of you know, on a lot of text as well. And the model that Google trained used a data set which was collected from the internet, without a lot of without any filtering. It was automatically collected, and that data had bias, and it was like yeah, that DALL-E 2 is the one from Fast AI, I think. That's their I think it's Fast AI, right? Okay, let's just check here. So DALL-E 2. OpenAI, yeah. So this is the company funded by Elon Musk as well. Okay. And then Google created their own model, which was, let me just check the, what's it? This one, Imagen. So Imagen, I'm sure it's actually similar to how DALL-E 2 was trained anyway. Use the data set. What is it called? It's actually an open source data set of like millions of images and videos. Oh yeah, this one, right? The Lion 400M dataset. It's a collection of 400 million image text pairs. The problem with this data, it's actually has bias. To fix bias, I don't know actually. I would guess that you would need to basically like you would have to handpick the data, filter it with someone, a human person, at least doing some part of the filtering, and then you can try to automate the filtering, but it's always going to have, it's probably always going to require someone with discernment. Yeah, but that's not really something I have tried to do myself, so I can't really say other than speculate. Okay, so going back to MediaPipe. We have to be aware that the AI is not as intelligent as it claims to be. Okay, that was this one. Okay, post classification. So we have this one is the one I abandoned because it was not allowing me to. What's this one? Selfie segmentation. That's the one. So AWS SageMaker Clarify. I want to try that. I'll have a look at that. So that's a suggestion from Dimitri. So let's see. Okay, of course there's an AI solution for this as well. It's cool. Yeah. Thank you. So let me go back. We have now an image here. I'm just going to download this. And then I'm going to upload it now. So I have to upload too. Okay, so API, the docs, and then segmentation masks. Okay, and we can use this segmentation mask and we can replace the background or blur it like we do in Google Meet when we don't want people to see what's behind us. What? This is not blurred, is it? Let's see the original image. I thought it's almost the same. Maybe the Gaussian blur is not very strong. Gaussian blur. Let's see that function. Just see what are the parameters there. Fix it, hopefully. Blur an image in Python using OpenCV. Okay, where's the example? I wanted the API. OpenCV. But the documentation from OpenCV doesn't come in the first place. So the parameters. Oh, Gaussian blur, and we have the first. So we can maybe make it a bit stronger. Just checking. Let's see if this. Okay, it's to be within the limits of the image. So what's this? Okay, this is not working. This is how I expected it to work, but anyway, it looks blurred. Maybe this is my eyes are not detecting a lot of it, but it's not a good example. Let me try another image. Okay, this is better. So let's download that. We have image to try this on. Let's hope the blurring works this time. But if not, if it doesn't work, I will not try to fix it now. mainly because I want to go into the JavaScript. It seems like the segmentation mask works fine, so there is no reason why we can't get this code to work properly. So the issue is not with MediaPipe, it's just the code that they've used here. I don't think it works. This is like the coordinates of the ring. It should be a kernel, right? Case size of... Okay, there's some constraints here. Anyway, it doesn't matter. Right, next one. I think... Okay, I'm done with the Google Collabs. They are quite useful to understand the main functionality available. And I wanted to see the JavaScript demos because they are also quite interesting. You can run it on a browser, it's more flexible. Let's see if they have any demos without... Okay, I don't want to install anything now. Okay, let's see, CodePen. So each demo has a link to CodePen. So let's try it. This is good. Okay, so I want to see the CodePen URL. Very tiny for even for me. Script. Okay, let's try this one. First, see the web. See a web demo. You can do some really amazing stuff with JavaScript now. I think I might do a separate live stream just to show you how the, like the WebGL in the browser really is amazing. You can do 3D. In fact, I've done something with that as well. I'll show you in a second. So ready to use Python solutions. What did I just opened the JavaScript version, right? The web demo. Okay, this is example. Here you can see you have to include some JavaScript libraries. I might just be able to copy this and try it myself in a browser, but I was hoping that they just have a website that allows us to easily open this without messing too much with. It's actually very, it's a bit hard to get to the right links. Okay, so CodePen, this is what we wanted. Okay, I'm not sure whether I'm going to be able to do this demo because it's going to try and use my camera. I'll see what happens. You probably... Yeah, it might not work for me because I'm actually using my camera. And it says it's so awesome. Okay, for the JavaScript version, oh, I'm using the wrong camera. Let me try. Oh, maybe I can use the OBS camera because OBS is a... No, can't use it. Because I'm already using the camera, to be fair. If I wanted to Maybe I just have to stop myself from being the camera. I'll switch off my camera and hopefully, yeah, this will work. We'll see. No? Okay, I don't think I can try the demo for now. This one is requiring a camera, but you can actually try it yourself. The links are here in the website, and you can do amazing stuff with the browser. And I'll show you something like I worked in React some time ago. You can actually run TensorFlow.js on the browser, and you can actually do a lot of I also have a demo with the camera, but obviously I can't use it right now. But you can apply style transfer, for example, models into an image. So I can, for example, I have here, this is all done in the browser using WebGL. It takes a bit of time to show up here, but it's going to show something, I hope. Oh yeah, I need to pick a photo. So I need to pick the photo. So I have like some examples here, like the turtle. A bit of time as well. You can actually, all of this is done via the browser, right? So what MediaPipe can do is actually something that, for example, TensorFlow.js can also offer you. You can actually convert any model from TensorFlow, pretty much almost any model. I would say there's some models you can't because they have some special TensorFlow operations that are not supported yet, but you can actually, any model, full-size model is okay. Of course it will be a huge model like this one, but if you pick a smaller model you'll be able to run it much faster, and you can even apply it in real time with a camera. And yeah, all right. Obviously I can't try this one. Maybe there's another one I can try. So this one requires a camera. Then maybe there's another one which doesn't. Let's see. Object detection. This is the one API I wanted to have. Yeah, this is cool. It's YouTube. This was also used in a challenge for the YouTube 8M. Okay, so as you can see, right, I think one of the important points to highlight in MediaPipe is that it's actually not straightforward to install it. Okay, I've tried to install in Mac OS, and the instructions that it basically requires you to compile C++ code and then install also OpenCV and FFmpeg, and it's not easy feat. And yeah, so you can actually, just for you to develop, for example, for iOS, it's actually a lot of work because you have to set up your development environment like Xcode, and you also have to do a lot of, yeah, basically you have to install Basilisk. I had issues setting it up, and there's a lot of complications here. One thing I'm going to try is to set this up for the Raspberry Pi. because all I want is to use MediaPipe in the Raspberry Pi. And I've already had a look at the GitHub repository. There's a list of issues there. Not this one. Where is it? MediaPipe. There should be a link to the code. Okay, so the MediaPipe GitHub repository is here. And then one of the things that you should always do when you go into when you're trying to decide whether you want to use an open source project, right, is to look at their, first of all, the last commit. Okay, I can see the last commit, well, the last merge to master, it was on the 29th of June. Yeah. So it's not like a huge, there's not a lot of activity going on in this repository, which means it's probably not, the support is not going to be the best. But this is open source, right? So you can just take the code and modify it yourself. And then we can also see the pull requests, which are useful measure as well to know. So the last pull request was 20 days ago. That was closed. Days ago. It's, I don't know how, maybe it wasn't merged to master, right? Oh, there's another branch. It's called Google Master. No. Yeah, it is good. Yes, master. Okay. Yeah. Okay. Okay. And the issues, right? Sorry. One sec. I need to post something. Yeah, so normally I look at the issues to see what kind of support is given to this. And you can see like some of the red flags I already see is the cross-compilation issues for Raspberry Pi. It was open 15 hours ago. And seems like this is not going to be the easiest things to set up, right? So I'm going to think very, very hard about whether I really want to have MediaPipe, because the last thing I want to do is to try and spend my life trying to compile things in. It's not a lot of fun. I've already done that in the past, and you don't really get a lot of return for that. So maybe there's a, I don't know. It's not something I will fancy a lot. If all I need is object detection, I can just use a TensorFlow Lite model to do that, because you have here the TensorFlow hub. If you look at the TensorFlow hub, it's like full of models now. You can just pick the one you want. Yeah, so you have all kinds of models. You can just do a search and see what you need to do, and then you just download the model. Sometimes it's already available for the TensorFlow Lite, already in the format you wanted, and you can just use that. Or sometimes it's not, but you can still convert it to TensorFlow Lite. I've already done that before, and you can see one of my previous live streams. I show you how to convert a model to TensorFlow Lite. So this might actually be probably the, yeah, I don't want to make up my mind just yet, but it tells me that I'm not sure I want to go through all the pains of trying to set up MediaPipe for the Raspberry Pi. Anyway, it's too early to say it, but I think that's all for now for this live stream. If you have, you know, I'll see you again in the next live stream, and happy coding.